Okay, hello everyone. In this live stream, we're going to simulate a rope. So I did a bunch of simulations before for the rope, and I don't know, I feel I can go much better, as you can see. So yeah, let's go, let's start. Okay, so what I'm going to do is let's just say we have a curve. Okay, we have this curve. There's like 3 points for simplicity on this curve. We're going to look for the previous index. For example, this one is 1, this one is 0, and the next index, which is 2. Okay, then we're going to apply tension for this particle, for this point, towards this one, this point, and this point. That's all what we're going to do. Then we're going to add gravity, which is a third force. Yeah. So the sum of the index, the sum of the tension, yeah, with the gravity is going to move this point. Then we're going to add collision and a lot of other stuff. Anyway, what do we have in here is, let me just delete this collider. We have 2 points, the controller point and this static point. Like, you can move the static one, but I don't know, they're just names. Let's see how we can do it. First thing, we're going to grab a curved line. Just okay. And yeah, here we go. Then I'm going to grab the two empties, the controller, which is going to be in the end, relative, control H, and the static, yeah, okay, relative, control H, and hide the node options. Now we have this thing, okay. Now we have only 2 points. Like, where is the spreadsheet? Okay, here it is. So let me just spin this. We have 2 points. So in order to just add more points, I'm going to resample curve. Let's say, for now, let's leave it on 10. Maybe, 15. Okay. What I'm going to do now is adding the simulation zone, because we will start simulating. So as I said, we're going to look for the previous and the next index. Then we're going to apply tension. So there is a node in the curve. Then I think read. I don't know, I just type. Okay, it's called curve offset or something like this. Offset points and curve, this one, which is going to offset your current index. So let's say my index is 7, for example. If I did this, I'll get the index 8. It will add 1 to my current index. Like, now I'm looking for the point which have the index 9. Okay, so I need the next one and the previous one. And what I'm going to do is to evaluate at index a vector. This is the index. Now I want to evaluate the position. Now I have the position of the previous index. Doing the same thing down, point index. Let me just hide this to make it look much. With that, we're done. What I'm going to do now is Ctrl J, store, maybe nearby position. maybe, I don't know. And let's hide the node options. Okay, now we're going to apply the tension, but I couldn't figure a way to make it go like this. Let's say two for like, let's say I have this one which is 5 meters. We're going to divide it by 2, so we'll have 2.5 for each side, like 2.5 in here, 2.5 in here. Then we're going to subtract this position, like, yeah, my position minus this one, right? This one minus my position. So this is going to be P final. This one's going to be P current, for example. So we're going to do P final minus P current. And the point is going to move this way. That's all what we're going to do. So how to do it? We want to store a named attribute, which is going to be our velocity. So let's call it tension. Tension. Yeah, that's it. Control G. Oh wait, shit. Okay. Reroute then Control G maybe, yeah. We'll call this rope tension maybe. Tension. Okay, let's hide the node options, go inside this node, and let's see what we're going to do. So we need two named attributes, which are vectors. This one's going to be, let's go to the next frame, next one, and the previous one. So yeah, we're going to get the sum of them. So vector math add. Then we will scale it by 0.5. So we have the sum multiplied by 0.5, so it will give us which direction should we go, like this or maybe like this. Okay, and what we're going to do next is to subtract our current position. Now we have this vector, which I'm going to store it as a tension. That's it. Let's test it. Set position. We need a named attribute, a vector, tension. Plug it in here. Now something is happening. To make it look much clearer, I'm going to add instance on points. Then I want to add some points. Okay, we're going to join these together. Here we go. Okay, you know what? The background is looking very dark. I can't see anything. Viewport view. Theme gradient. Something like this. Let's start the simulation again. Okay, shit. We have to do this after. Okay, like this. Yeah, it's working, kinda. So what is happening? each point, for example this one, it gets the sum of this one and this one, then it tries to go this way. Then it's centered, but now this distance is smaller than this one. So this one's going to go this way. And like this. The same goes in here. This one's going to move like this. Then this one's going to move like this because you've got the idea. This one's going to move like this because after this one's going to fix its position, this distance is going to be much smaller than this one. The next frame, this one's going to be fixed. This distance is going to be smaller than this distance. You've got the point. Let me just, it's locked. Okay, so what we can do is in the set position, I'm going to add endpoint selection, not, and with that, let's see, nothing is going to happen. Why? Because the controllers are not doing anything. Okay, in the first frame they're working, but once the simulation starts, it will just stop getting any input from outside the zone. So yeah, let's make this happen real time. Just add options and control hide, stack this. Same thing in here. Let me just call this one tension. Alright, so I need to set positions. 1, 2. The first one is going to be, let me grab this. This like here, and this one is going to be in here. Control H to hide them. Then I want to get this controller, plug it in here, relative, close it. Same for the static one, location, set position. Not sure if I have to flip them. No. Nice. Okay, it's working. So something that you might have noticed, that the rope is so slow. It's fixing itself, but it's so slow. Wait, let me call this handles. Right. Handles. I'm not sure if I spelled it right, but never mind. Okay, how can we make this rope fix itself much quicker? Very easy. So if you ever heard about something called subframes, we're going to do this calculation, the rope tension calculation, like 50 times in each frame. How we're going to do that? Using the repeat zone. But we're going to put this entire set position inside, because after setting each position, like this point is going to move a little bit, but if we just store the vector, it's not going to move, nothing is going to change. We're just overwriting the same vector like 50 times if this one is 50. Okay, so we need to actually set the new position, then set it again like this. Every time it's going to update and offset. You've got the idea. So from here I'm going to connect this like here. The simulation zone got broken, and yeah, like this. Now let's have a look. Shit, it's not doing what it's supposed to do. Let me just take this out of the loop. I don't know if it is faster or not. Wait. Let me just put this one inside. Yeah, here we go. It's so fast. Okay, so 25 maybe? Nope, that's too much. 15 maybe? No, it depends on your frame rate, so I'm going to increase it. Okay. In here, custom, the max I can go for is 75. Let's check. Here we have 0 viewers, 0 likes. Shit. Now, as you can see, it's working. Alright. Okay. Let me go with 5. No, 15. Okay. The next thing I'm going to do is to add gravity. How am I going to do it? Is very simple. Just a vector math. We're going to add something to the tension, which is going to be a small amount of gravity. Now we have gravity, a real physics rope, which is hanging in 2 points. But as we can see, it's not damping. I don't know, I'm going to do the damping later, maybe in another stream. But for now, that's so cool. So, okay. The more we increase these iterations, is anything going to change? The answer is no. The gravity is not changing. Why? I don't know, to be honest. But if it works, it works. Now, what we're going to do is to, yeah, apply collisions, maybe. Let's add a plane, ground, floor. As you can see, the rope collides with this. So how to fix it? Let me just disconnect this. Store named attribute, vector, going to call it velocity. I don't know, velocity. And let's plug it. Then we're going to just get a new named attribute, the velocity vector, plug it in here. The same result, the same result. We'll call this gravity. Alright. Let's add some space in here. Now, for the collisions, what I'm going to do is using Newton's third law. So this is our velocity vector. For example, let's just go back. Okay, it's happening very fast. Let me just increase this down to 10, for example. Oh shit. Okay. Something like this. So, as you can see, each point is moving down, but at the same time in this direction. So the sum of these two vectors is something like this. Let's say that we can shoot a ray. This ray is going to have the same radius as this point. So let's say we have, where is that? Where is that? Here we go. This radius is 0.1, so we're going to shoot a ray with a length of 0.1, which is not going to work. There's a better solution. We're going to shoot a ray with the same length of our velocity length. So in the next frame, we're going to be, this point is going to be, for example, in here. Not sure if, I think this point is this one, maybe. Yeah. Okay, so we moved from here to here like this. So if I want to shoot a ray which have this length and this direction, if it hit something before setting the position, so it's going to check shoot a ray with the same length of the velocity that we're going to move into. I don't know if I said it in the right way. Anyway, if it hit something, we're going to add something to this velocity, which is going to be, I think, the same length. Yeah, the same length, because Newton's third law. So we're going to add the same length as this velocity have, and the vector is going to be the normal of the hit position, of the hit surface, the hitted surface. Yeah, that's it. So yeah, we're going to do a raycast. We're going to bring the collider collection, realize instances, the geometry into the target geometry, hide this. Now what we're going to do is to add something to the velocity, which is our hit normal. Add. We're going to add this to our velocity. So plug this one in here. This new velocity is going to be our current velocity. So Alt P, store named attribute. This is the new velocity. We want to do something in here, right? We have this velocity, which is going to be our ray direction. The length is going to be the length. And what do we want to do? Okay, we want to scale this, scale the hit normal, because it's normalized. So we want to scale it by something. This thing is going to be our length. That's it, I think. Let's test it. All right, it's working. Yay. Except this point, I don't know what's going on. Let me just stretch it. Yeah. So when collapsing it, what is happening is I have no idea. Shit. Okay. Yeah, okay. So I'm going to add another check. Scale. If it hits, no. If the hit distance, for example, we're going to shoot a ray like this. It hit something. How do we know that it hit something? Is by comparing the length of the ray, which is our length, by something, by the hit distance. So if the length of the ray is greater than this hit distance, then we've hit something and we want to continue this collision thing. If we did not, then we don't. So if the hit distance is this, then, or the length is greater than, the same thing, is less than this, yeah. Let's give it a try now. Yo, it's working. We still have this point. I don't know what's going on with it, but yeah. Okay. So something. Wait, before saying about that thing, Control J. I'm going to call this collisions. Yeah, nice. Okay, yeah. Something that I want to show you. We have currently 5 iterations. Let's go to the next frame. So this point, for example, this one is here. The next frame it's currently here, right? Let me just pick another color, add a new one, look frame. I want to make this one red. Let's increase it up to 50. So currently this point is here, but in the next frame it is here. So the more we increase the iterations, the more gravity will, the more effect of the gravity we're going to have. Why I'm telling you that? Something that I faced while testing with these robes is when I increase this, for example, let me just remove the collider, move it up. What? It's updated. What? Wow. Even if the simulation is not running, it's not the best, but it's working. Anyway, let's increase the resample up to 100, for example. Let's restart it, and as we can see, the gravity is going to affect these points much more. Why? So each point is going to have this gravity downwards, downwards, downwards. The more points we have, the more sum of the gravity we're going to have on the entire row. How do we fix that? By controlling the iterations. I know it's a stupid thing, but let's say we have 50 points. Then we have to do the iterations. The more iterations, the more effect of the gravity. So we're going to do, for example, 15 maybe. Let's have no 1. Shit. Let's test it on something like 15. And the final position is going to be this. 2 iterations, it's going to give the same result much quicker. How can we control this? Let's think about it. We have this curve. The more points, the more gravity we will have, right? So we want to decrease the gravity, but increase the repeat iterations. Okay, that's making sense, I think. So I have this gravity, which is going to be, okay, which is going to be based on the count. So instead of always getting out and going to the resample curve and resampling it and all that stuff, then controlling this, what we're going to do is to add a reroute, Control G, delete this. The output is going to be called, let me delete the input, resample count. Count, just for simplicity, count. We're going to go from 0 up to any number. Let's start by 15. This node is going to be controllers. By the node group. So the more resolution we have, the more iterations we will do, but the less gravity. Because if we did a few amount of iterations, we decrease the gravity, the rope is going to just move slowly. The next frame is going to move just a tiny bit. The next frame a little bit, like, okay, that's with the low gravity. But if we increase the iterations, it's going to go like this in 1 frame instead of 2. Here's the first thing. So with a higher gravity, it's going to behave as it have. So I don't know, it's a proportional thing. We currently have this amount of gravity which is going to be based on this control. So let's scale it. Node options, scale. I want to scale it by something. Let me hide the node options. Okay. I want to scale it based on this. So the more count we have, the less gravity we are going to have. So yeah, let's divide it. Division is going to work, I think. So if we have a resolution of 2, let's say we have a resolution of 2 points. Let's say 5 maybe. Wait, how many we have now is 15. So if the count is 15, we're going to have the entire full power of the gravity. If it's more, we're going to decrease it. So 15 over 15 is going to give us 1, which is the current one. Let's say we have now, for example, 30 points. Then the gravity is going to be half of the current one, like this, but it will move faster because we increased the count. So yeah, let's connect this. Not sure how it's going to behave. Yeah, okay, the same thing. But what will happen if I increase it up to 150? Let me just compare. Shit. Wait, instead of 150, let's go with 50. 25 maybe? How much gravity do we have? Let me go with the spreadsheet and have a look. Maybe I'm going to map range it. Maybe, not sure. So let's have a look. Viewer 0.6. 15 is going to give a total of 1, 13, 30, right? Yeah, 30, not 13. 0.5. Let me disconnect this and have a look. We want something less. So let's say, for example, 1, which is going to be a very, very, very low amount of gravity that is pulling the rope downwards in the same thing, the same way. Shit. Okay. So this way did not work. Shit. How can I fix it? Is by maybe grabbing the gravity outside the loop, the repeat zone loop. I don't know, I'm testing stuff. Gravity into the gravity here. Let's give it a try. Wait, the simulations. Oh shit. Seriously, shit. Let me just do a scale. What the what is happening? Wow, the tension. Alright. So instead of adding all that stuff, I'm going to just add the tension inside of the loop. So we're going to do a vector math where I'm going to do it before storing the velocity. Where is the last place I stored the velocity? Here we have the tension. Here we have the collision. In here, I want to add the gravity, I think. Hope it's going to work. So next frame, gravity. Where is the gravity? Man. Why is this thing called velocity? Huh? So I'm going to call it gravity. Gravity, here we go. In the collision section, I'm going to search for gravity, add it in here. Let's see. Oh shit. Shit. That's definitely what I don't want. So with that, we don't have gravity, but we can still. Oh shit, the rope is not being fixed. Why? Because we have the tension, we have velocity. This thing is controlled by the velocity, controlled by. Yeah, we have to add the tension. Stop the simulation, man. Okay. Instead of adding, okay, we have to add first tension, which I can't read because of I don't have any idea. Yeah, here we go. The tension. Now it should do something. I'm not using the gravity, right? So in the rope tension, I'm going to add the gravity. Add the gravity. No, it's a named attribute. What the fuck am I doing? Vector, which is going to be the gravity, which I can't see. Man, I changed its name, right? Gravity, the rope tension. Here we go. Then, instead of calling this tension, I'm going to call it velocity, and now in the collisions, instead of adding the tension, I'm overwriting the velocity. As we can see, yeah, let's have a look. It did something. Let me grab the controllers, the count, plug it in here. 30 iterations, right? So let's say 15. Okay. 100. Okay, so I have to map range the gravity, I think. Map range the scale instead of the division. Map range. Why do I have this? Okay, I want to map range a value of 1, which is the gravity. The maximum is going to be our count. The minimum is 15, maybe? Let's go with 15. So if the value is 15, then we want 1. Otherwise, we want like 0.0501. That's too much. Add another 0. Do I have to just do this? Damn. Something is wrong. Let me add another 0. Just, I think something is, I don't know, something is wrong. What the? Control, add this to the value. Nothing is happening. Increase it. Something is happening. Divide it on 2, maybe? No. Yeah. So let me divide it on 0.04. So let's put the count down to 50. 15. 50. 200. If Okay, what is happening? Let me just, I don't know, think about it. So we have a value. If the count is a high number, then I want to scale it down to a very small number. The maximum value is going to be, it's going to just give me this value, but I want it to update when playing with the count. So yeah, I have to now drop it down to 0.2, for example. But that's not what I want. So let's see. 100 is going to behave very bad now. Yeah, that's cool. 15. 50 is going to be very bad. 51. I don't know why. Maybe 25? What the hell? So 100 plus 15 over 2. Just want to see something. Okay. 100, I don't know, 70. So the more I go to 15, yo, it's increasing very quick. That's the reason. Decreasing, I think. Yeah, it decreases in a really, really, really quick way. So here is what I want. When it was 100, something like 0.02 was looking nice. 200, no, it was 4. 200. 0.02 was looking so good. What is the relation between them? The more you increase, the more it has to decrease. So let's say 1 over 100. It's going to give 0.01 times 4 is this value. So 200, it's going to give 0.05 times 4. Yeah, let's try it. The count, 1 over the count, divide 1 over the count multiplied by 4. Let's give it a try. What is, yeah, that's 15. Okay, 100. Okay, 200. Okay, nice. Maybe times 3, 2. Okay, I have 200 now. 100, back to 100. Nice. 15. Maybe 5. Let's try 5. Yeah, so maybe if I decrease this down to 5, nobody's going to enjoy doing it with 5. You can't have good collisions and all that stuff. Something like 15. Why it's not updating? Stop the simulation, buddy. Yeah. Let me bring down the collision, the collider. Try it with a high number. 100 points are going to collide, which is behaving really nice. Okay, so as we can see, we are in this issue where the points can just go this way. I have a small fix to it. I think it would work. So let's see what we can do. Let me just put this into a collection. No, not this. Okay, this one is going to be in a group. Fix gravity. based on resolution. Resolution, I think that's how it's written. No, resolution. Nobody cares. So something like this. I don't know. Control G. Let's call this one gravity. Gravity. Hypernode options. Bring this here. The iteration count in here. This thing in here. Nice. Let's put the handles here. So let's see if there's anyone watching the live. I'm stream, right? Yeah. I'm streaming live. And stream health. Okay, anyway. In here. Alright, okay. After cleaning this up, everything is looking good. What I'm going to do now, let's think. Yeah, the collision. Let's go in here. Remove this. Let's call it friction because it's, I don't know. Anyway, so we have a point here and a point here and yeah, and another point in here. So the sum, let's just draw the rope in a different color. The string, the curve. Look frame. We have this. Oh, that color's bad. Dark blue. We have this situation where the point is trying to go in this direction. We have the sum over 2, then the point is going to go this way. But the collision is pushing it this way. How can we fix this? Let's say, let's see something called tangent. So the tangent is going to be a tangent, I don't know. But it's going to be drawn like this in here. And our vector is going this way. So if I projected this vector on the tangent, I'll have this small tiny little vector. So let's see in here, after projecting this, I'll move this way. So I'll start sliding down so slightly until I reach this point, then I'm going to move this direction. That's a solution, but let's mix between this vector and this vector so we can have this vector, which gives the actual tension, I think. Don't know if it's going to work, but let's test it. So yeah, we have this vector. I want to project it. Project on the tangent. No, what is that? Curve tangent. Then let's have a look. Yo, it worked, but what the why it's behaving like this? Wait, the gravity is not working anymore. I think something is off. What the? Okay, after I collided, some weird stuff are happening. it's fixing itself, but in a very, very weird way. Anyway, let's try and mix between them. Mix vector with a factor of point. Yeah, okay. Okay. Oh shit, what is that? Okay. So if I decrease this, as you can see, something like 0.25 maybe is going to be good. So now I can just slide on the angles, which is cool. Let's go to the first frame, drop this down. But as we can see, the gravity is kind of broken. Why? Where am I adding the gravity? Is in the collision, right? This attribute is velocity. Where is the gravity? Where did I use it? Store nearby position. I don't think. We have the velocity. We have the aimed attribute velocity, but the gravity is tension. Oh, okay. So all I have to do is to grab the gravity out of here and instead just do something like this. Now it should work as expected. Let me just throw it down to 0. Yo, shit, man. Let me just do something like this. Oh, holy shit. Okay. Now it fixed itself, I think. So all I did was just projecting. Look at this. Like, why? Let's go with 0.5. The tension. Wait, yeah. I think I figured it out. So we have this point. We have this point. We have this point here. Let's grab the white color. So the tension was pushing us this way. Now it's pushing us this way, right? So instead of shrinking the shape down, we are inflating it. So yeah, I think then after the inflate we add the gravity. So the sum is going to be something like this. But in this one, in this case, what we're doing is just moving a small amount like this. Yeah, that's it. That's the point. So something like this, and exact like this, must work, but why? Okay. Let's scale this one, this vector down. I think that's going to fix it. So let's scale it by something. So the more we scale it, the more effect of the wait. Yo, I'm scaling it down. Yeah, that's what I want. Right? So with that, no, I want to. No, holy shit, man. Let's see. Damn, what is that? 0.5. Okay, don't scale it. That's going to make a disaster. Increase it and you'll see. Let's scale this one down maybe. But we have to fix something in the gravity later. Wait, let's scale the entire vector. So let's scale it by a small value. A very, very small value. Never mind. Okay, something is working. So, yeah, we have it. A nice looking rope. Let's try and do something with this rope. Let's say we have a fixed length for the rope. Like the rope should be only 2 meters, for example. Otherwise, this handle is going to be disconnected, maybe. Not disconnected, but what I'm thinking of. Let's say we have this handle, this one. Our maximum curve length is going to be, for example, 2 meters. And this curve is trying to go up to 3 because of the stretching. Then we want to do something like this. Like this point is going to move towards this. It's trying to push it. We're going to add more tension to this point. Then all the other points are going to try and fix their positions. Maybe. Let's try and do it. So what I'm going to do, under the controllers, I'm going to add a new output. Maximum length, like this. Let's set it by 2 maybe now, and hide it. Where am I going to use this? Let's go to the handles. Okay, this one is the static, right? Okay. What I want to do, let's say we have this static point, the static handle. Let's say that based on the distance between me and the handle, we're going to set this one position. How? Okay. Let's say that our curve. Wait, yeah. The more tension is going to be applied, the longer the vector is going to be. That means the longer our rope is, right? So maybe we're going to do a map range between the length of the vector and something in here. Like the longer the vector, then the more or the less effect we're going to have in this position. So we're going to mix between it and this location maybe. Wait, let me just try and mix between this location, mix vector. What is that? Mix vector body, vector. What? Why color? So we want to mix between this location and our current position. Let's have a look at how is this going to be. So with that, nothing is changing. Something is changing. So let's decrease it. It's moving towards this location so slowly. And literally based on nothing. Let me just decrease the count down to 15 maybe. It's much faster. 5, yeah. Just doing a simple thing. Alright, so let's go back to the handles. So, okay. Now it must be not connected. Yo, I think, yeah, this one. So the start size is going to be 0. Now in here, we can see something happening. Yo, is it working? Yo, damn. Okay. So let's say I'm here. Then, yeah, I want to map range this distance. So let me just set it up to 0.6 maybe. 0.5. Yo, nice. What I want to do is to do a check. For what? For the curve length. For the curve length after this happens, maybe. Yeah, after, yeah, in here. Curve length. Here it is. If this value is greater than controllers, this one, because as I said, I have another test in here. You know, I'm going to do something. Wait. We want to do something, okay? But before doing this something, I want to hide this. In the test one, let me just pick it. I want to add a dot in each node, before each node. So now I can't find them in here. Let's see. Detention. Endpoint selection. Okay. Node options. I'm going to add a dot. The self collision. Adding a dot. This one. Let's add a dot. Inside of here, the collision vector, I'm going to add another dot. The handles, I'm going to add a dot. You know, it's written with a big mistake. Anyway, so currently we have controllers, collision, gravity, handles, rope tension, rope test. Okay, nice. Much cleaner. Let's get back in here into the handles. So what do we want to do is, if the length is greater than, then we want to increase the mix. I think to increase it. Yeah. So let's see the ratio that we are looking to. Based, okay. I want to just mix between them based on the length. So let's get the length into a map range. Let's collapse this or hide the node groups. If the length is equal to the maximum length from min, then the mix is going to be, I think it was 0, right? Yep. So we want to have 0. But if this curve length is greater than, which is going to give us 1 to this thing, then let me test it. I'm not sure. Like, I feel I don't know. So currently the curve length, I don't know how much it is. And yay, it is not working. Let's try and put this in here. Let's see. Yeah, like the same result. Let me pin this. Grab it out. Put it in here. Let's have a look at what do we have. The curve length is 2.7. So this thing is true because this thing is true, which is 1, the maximum length is 2, yeah. No. Okay, okay. So here it is, the ratio between these two, which is the length divided by this. Wait, let me just flip them and try and plug it in here. Let's see what will happen. Okay. When I try and just damn. It's shrinking too much. I want the shrinking to be controlled by something. So this value, if the curve length is 2.7, and I'm 2 over 2.7, which is around 8 maybe? 0.8 I think. Something like this. So this value, the more difference in the length, so let's say it is perfectly 1, we want to return the full power of A. We want to return this, okay? If the ratio decreases, we want to let's give it a try. Maybe we want to flip something. Maybe let's flip this and this. That will not work. No, it's working. But as we can see, the rope is stretching. Now, yeah, nice. But now the rope is not perfectly 2 meters, right? Let's have a look at the curve length. Let me just collapse this. The geometry is, let's say this one. The curve now is 4 meters. So based on this, let me just collapse this. Okay, let's continue. Okay, so what I can do is using the trim curve, but it will cause an issue, I think, right? Trim curve. So by trimming it, let's add it out of here. In here, yeah. The more I trim it, as we can see, now we lost 1 point. Let me just pin this. Let's say that we want to see the curve length after the trim. Curve length. Tick tick. Now what do we have is 5. Damn. So now it was 7. We have to get rid of 1 point, 2 point, 3 point, a lot of points until we reach this. That's not going to work. we have to do another thing, which is increasing the tension maybe. So go into the rope tension and let's try and think how we did it. So the more distance we have, the more we're going to just move, right? But let's say based on this distance, we want to map range it, maybe, I'm not sure. Based on this distance, we have this vector that goes this way. Then we projected it the tangent, so we have no friction. So it's currently like this. Based on this vector length, which is projected, let me just I just want to do something. I want to grab this back. Now this curve is 2 meters or less, right? But it's not fixing itself. Why? What will happen if I did the same thing to this one? Is it going to collapse? I don't know. So let me just grab this from here, which is going to make no difference. Then I'm going to do the same thing. Let's see. The location into the location, the map range into here. Let's mix between the positions. After that, oh wait, nice. After that, I'm going to just now the controller is disconnected. But with this, why? Yeah. Okay. What is happening is what? If there is no previous vector, the point is not going to move. Right? Wait, let me check the indices. Pinette, let's have a look. Yeah, here it is, this one. This point does have the index of 0. And based on that, if the index is 0, wait, let me just go to the fixed rope where it is, rope tension, yeah. If the index is 0, we want to look only for the next one. So if the previous, wait, next, maybe in here, let's do it in here. Let me copy this. No, I don't think. Curve offset. Curve offset. Based on the point index. Yo, I've got an idea. Okay. The previous one. If it is less than 0, we want to what? Just a second, let me just bring this back up to here. Okay. If the index is less than 0, which is negative, which does not exist, I want to look only for the next one. I want to move towards the next one with some amount. So let me just grab this, Control C, then remove it from here. I want to store this in here. If the board is empty in points, then not plug it in here. Let me just see if it's working. Start point. Yeah, all right. So this one is going to be like this. Then I want to store another velocity only for the point which is the start point. This velocity is going to do some cool stuff. So let me just frame this. Mid position, then the vector, let me just this one's going to be the vector direction, or direction for simplicity, direction. This one is going to be projected vector, and this one is going to mix between them, which is going to be a fixed vector. Then we have this addition. Okay, this one is going to be add gravity. F2, add gravity. And I don't care about this. Let's just drop them like this. This entire thing without this. This entire thing is going to be index is not 0. Let me just put this one in here. Now let's grab this. If the index is negative, then we want to look for the named attribute, which is the next one, next index position. We want to subtract our position minus this position, and that's the vector that we're going to move in. But we want to scale it with some value. So let's think. If the piece is longer than, for example, we have 2 meters rope, 1 meter for simplicity. This rope is made out of 1, 2, 3 points, which means 0, 1, 2. Okay, so each point or each edge is going to have a length of 1 over the edge count, and the edge count is the maximum index. So we need an attribute statistics. We're going to get this one. Here it is. Plug it in here. We are going to look for the index, the maximum, into array root. Let's collapse it. Then we want to get the curve length. Divided by the maximum one. Now we have each edge length. Not each edge, like the final one. Right. Not right. Yeah. Each edge length after the rope is being fixed. Like, we're fixing the rope in here, right? Okay, so what we're going to do now is to subtract from this, the long one, we're going to subtract the length that we want each piece to be, because all the other pieces are going to be fixed and go towards this vector, and this one is going to move this way, I don't know, I think it's going to work. Just let's see. So each edge length is going to be the same thing. We're going to do another division, but instead of this, we will divide it by controllers, maximum length, plug it in here, hide in the node options. Now we want to subtract them. Subtract. And this vector, let's scale by, multiply by 2, 9.5. That's it, I think, because I don't want to move the entire distance like in a quick way. I don't scale it like this. Then yeah, okay, everything is looking right except the gravity. We want to add the gravity. So Control C, Control V. The vector is going to be the vector, and with that, let's have a look at what is going to happen. Nothing for the moment. And hell no, why it is not working? Maybe just uh, 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 uh. It's doing something, right? Let me just remove this. The distance increased. Wait. Okay. Decreased. No. Something weird is happening. Oh shit. Let me just add an reroute and let's see this one. How is it behaving? That's so weird. It's moving based on this one. Why? The next index. Wait. Okay. We want to multiply this to scale this by the result. So if it's a true, now something different happened. Why? Let's flip the. Oh shit! Let me just scale this by 0.001. Another 0. Let's see. Still not working. Let's see the next indices position. Right now I'm going to do it manually in here. Index offset, curve points offset, curve points offset. Okay, then we want to add one. Evaluate the position vector. This one is going to be the index. This one is going to be the position. You know, we're going to evaluate this. Like it's that simple. And let's have a look. Why? What is going on? So what is this value? Let's have a look. View or not. It's near of 1. What does that mean? Okay, let's see. 1.4. Wait. Each point is currently 1.4, but they have to be 0.5. So the difference is 0.9 meters. So this point is going to move 0.9 meters, like 1 meter this way, which is the difference. So if I just grab the ruler, this one is a 3. Oh shit. Okay, so I did a small mistake. This one's going to go this way, but if I grab the length, let me just see the length. Yo, here it is. So here's the new change. Instead of doing all that stuff, I want another attribute statistics, which is going to be taking the maximum length, plug it in here, and the curve is flying. Let me disable the repeat zone, which will cause a lot of shit. Like, there's no difference. Back to not the collisions, the rope tension. So we have, I'm adding this only to this one. I'm overwriting only this one. So let's see the named attribute, velocity vector. Let's have a look. Each point is having a value of 0. The next frame, something weird happened. So yeah, I have a different idea. Instead of doing this, I'm pretty sure it's because of the storing. I want to do another thing. Let me just remove this big frame. Grab this one down. Let me just see this vector. No shit. Okay. Let's have a look at this vector, how much it has to move. What the f? What is the maximum? What the fuck? Huh? Okay, let's go here. The maximum one is 3. Then it's, yeah, 5, which one? Just increase this. Okay. Let's have a look at this. Okay, so the one which have the index of 0. Let me just disable this. Let's see how long is this. 1.8, right? Let me evaluate the length on an edge, maybe, or just see the distance between them. Okay, it's going to give the same thing. What? 1.8, right? So after the subtraction, I have to move 1.3. I want to multiply it by a small value. Now I have to move in. Okay. Then I want to do an index switch. Not index switch. Normal switch. Based on a vector before the gravity. If the index equal 0, then okay, let's see. Yeah. Shit. Now, some weird stuff are happening. Because I'm mixing between them. So what should I do? After reading this named attribute, which is going to be the velocity vector, in the viewer, point with the index, point 2 is having the most effective one. Now it's very small. But why it is not moving that way? So let me just remove this. Okay, so I'm storing its vector velocity index 0. Okay, why it's not working? Maybe it's something because of the collisions, I think. So what is happening in here? Let me mute the collision. And this thing is not going to warp tension. So it must move that way. And I'm going to try something different. I'm going to duplicate this, add in the vector. I want to store a different named attribute. So this one's not going to be affected. No, just leave it. Store another named attribute. On this one, this point, which is going to be I0, index 0. Let's add another set position, which is going to be, let's go to the next frame, I0. Let's, what the hell? Scale it. Let's scale it to see what is going on by a very small amount. And in here, I want to just do this. So when I go to the other direction, so let's just disable this. And now something weird is happening. So we have 2 points overlapping, I think. What was that? I see. Right. Let me try and store it before. I'm pretty sure I did the right thing. Now, let's have a look. Yeah, the same thing. And the rope is broken. What? Hmm. Let me just in here. No, here. Just connect this directly. Let's see. Perfect. So the curve length, let's have a look. The curve length is currently around 3, which is not bad. Let's see before how it was. Before this one and after. Nothing has changed. So all this was useless. Let's just pin it. Let's disconnect and see what is going to happen. Remove this. The start size. So what is this vector? Let's oh shit. Okay. As I said, it is currently curve length. I think I have one here. No, curve length. Oh, length body. Let's see the length. Viewer. Should I just pin this one? Yeah. Okay. So the collisions are disabled, I think. I'm not sure. Yeah. They are working, but because of the index 0, they're not. It's given different values each time. What? No. How can I fix this? Yeah. Now it's much better, but with a broken physics, as you can see. This one, yeah, I disabled it. When it's connected, I have to play with map range a bit. So maybe we're going to go with ratio. And the orb got broken. Oh, okay. Some weird stuff are happening. The handle, it's connected, but it is no longer working. You know, another set position. Yeah. So let's test it only on the endpoint selection one. Let's have a look. Same thing. Maybe I flipped it. I think. Let's try stupid thing. Yeah. So after scaling this vector by a very small value, something is happening. the vector. Okay. Hmm. It's not doing the right thing. What if I in here just connected this? Now the curve length is very small. Let's have a look. It is, wait, that's way too much small. 0.8. Why? Rope tension. Let's have a look. The same thing. So I have, wait a second, I think I know. Oh, this one's still put down, yeah. Definitely not this one. What is going on is we're storing the gravity in here, right? So I want, what is going on is because of the gravity we're pulled down. Okay, that's affecting our curve length, each piece length. So the maximum length is going to be this. I think add, then we have to go to named attribute, which is going to be the gravity. The next frame, gravity, we're going to just look for the length. Then we're going to add the gravity. Let's test it. Something happened. Something happened in the handle one. If I connected this, the entire rope is going to fake. Yeah, it's working now, but something cool is happening. So I want to do something in between these two values. Currently we have 0.8 because of this is not working, because I want to store it on something different. So now switch. I want to switch between vectors if the index is equal to 1 to 0. Index equal 0. Let's have a look. Now it's supposed to be 2 meters. Curve thing. That's the curve. And no, it is not. Let's see if it is because the gravity. So we don't have gravity now. Is it 2? An exact 2? Or tension? Yep. Without the gravity, we're getting an exact 2. But the gravity is screwing it. So let's try under the rope tension to add the gravity upwards. Yeah. So how are we going to add this? We want to add something to these positions. Then we're going to just do all that stuff. So combine XYZ, combine XYZ. I want to add to the z vector the length, named attribute, the length of the gravity. Next frame, gravity length. With that, I hope it's not going to break. Connected. Control Shift D. Same thing in here. We want this. Let's have a look. What is the length? Curve length. It is 2 point something. Let's do the same. Wait, let me check if it's working. Yeah, the gravity is working. Everything is nice and smooth and yeah. So this position, we're going to add the gravity to it instead of adding it here. We want to add to each position the same thing. Length combine XYZ. Shift D, Alt V, move it to here. Then we're going to Shift D, add this, and no, this one like this. Let's have a look. It is 2.5. So let's say that our maximum piece length, we're going to add something to it. Subtract the length of the gravity. Now it has to work. Why it's not working? Okay, I have no idea, but that's approximately true. So let's go in here and try different values like 3. What is the curve length now? 3.2 something. What is this 2 point something? String. I want to do something in here. Curve to string. Yeah, value to string. To string. And the value that I need is the curve length with a lot of decimals. This string is going to be string to curve. And this curve instances, I'm going to join them. Then transform geometry. For quick, I want to write it now. 0. Now we can have the exact length. Let me increase the decimals. Okay. Let me just fill the curve. Control H, Control H, fill curve. No, yeah, not fill. I think this one. No, yeah, fill curve with n-gons. Nice. We have something to see now. Let's collapse this. We have this 2.35 something something. When the length is 2, we have 3. When the length is 1, we have 0.6. When the length is 5, so the longer the curve, the more accurate it will be. Why is this? As we can see, the gravity is screwed. What the hell? Okay, let's try and go here to the handles, plug this in. In here. Wait, let me just add this as another option. So I want to group all this stuff. Oh. Okay, let's just copy, then group this as, for example, test1 alt v. You know, fix maybe. Then Control G. Wait, I want to connect this one this time. Control G, or before adding the Control G, I want to just remove all that stuff. I want to remove this, yeah, and this one, this one, this one. Control G. This one's going to be maybe test2, or wait, no, this one's going to be fixed. This one's going to be test. Then into switch in between vectors. So let's plug them. So currently I'm looking to the test, which is no shit. Okay, let's have a look at the fixed one. The same thing because of the handle. What is going on here? Maybe there's something wrong inside tension. Currently in the fixed one, I'm subtracting 0.5. I think that's buddy. Let's just get rid of this, and let's have a look. Yo, that's too much. I wanna eat something. There is a point that is moving in a weird way, as we can see. But what point is this? I have no idea. Alright, I'm back. So let's continue. Wait. I'm thinking, what if the less this distance, the more we're going to push in this way. Not sure. Problem is that there's no viewers, you know. I'm the only one talking to myself. If there's someone who could help me, never mind, in the future maybe I'll be famous and all that stuff. Anyway, let's hide the node options. Go into the test because we're going to test some stuff. So let's say that I don't have this one. Interesting. Hmm. I have no idea. Like, why is this happening? When enabling the switch, it just goes with very high speed. Maybe because of stacking these together, but no, I'm not stacking them. What will happen if I just connected this? Let's just mute the gravity. I don't need the gravity into my scene. Oh, I move this. There's no change, like literally. This one's doing something. Why? Let's unmute this. Try and see what is happening. What distance is this? Let's just remove this, this, and this, and this. Let's remove this one too. Yeah, let's remove this. Yeah, we don't want to add anything. All we're looking to is, at the moment, what the hell? Yeah, I have to take the lane. Sorry about that. Okay, let's do the subtraction. And some points has collapsed. Let me just Ctrl Shift D. I want to plug this in here. But the same thing, like if the index is, you know, right. So just wanna look to this point. Something is happening in here in the handles. So based on the curve length, the maximum length, okay, if I just disconnect it, then nothing is going to happen, right? Right. In here, in the test, I'm currently connecting the test, yeah. Let's just reconnect. The current curve length is 5. Let's scale down to 2. Now we have 3, which is too much. So let's see what the gravity is doing, because without the gravity, when I disable it, let's go and replay it. It is it's working. Like, look at this body. Even if I squished the rope, it's working. So how am I going to fix it? Let's see if the handles are going to work. That's the first thing. So yeah, it's not going to work definitely. What is this? Okay, so we're going to start by playing in here. In the test, let's plug only the false one with no gravity, and they collapsed. Let's plug this one, only this, and wait, what? Yeah, like this. They're going to collapse, but this one is going to lead to something. The entire combination, the total combination. So there's 2 points overlapping. But with that, it's working very well. So if I added to each position the gravity, which I did in here, but not in this one. So let's try and do the same thing again. Add and add. Let's add this vector like this. Let's go to the gravity and add a small amount, just a fixed amount. So I'm going to add minus point. Let's see this. How is it going to work? Okay. We have a total gravity of minus 0.1. Right. Right. So I'm adding to each vector, to each position, I'm adding the gravity upwards. What I can do instead of doing all that stuff is just Control Shift. Now I'm going to add it, but scaled by -1, -1. With that, we're getting the same thing. So let's just try and connect this one. It collapses as expected. Let's say that we're going to just do this. Even some weird stuff started to happen. Wait, the handle is disconnected, right? Right. So now, when it is stretched, no. What is going on? So without adding the gravity, let's add nothing. Exactly 2. With the gravity, let's add half. 0.5. So after adding 0.5, we have the exact half amount of the curve length. The more we add, the more it will stretch, right? Let's say that our curve length now is, for example, 1, an exact 1. It's 2, 5, it's 2. Why? by subtracting some small amount. It's not updating. Did I miss something? The max length is 5. We're adding gravity to each point. The store position, we have nothing to do in here. This one, we're connecting the test. And which one of the test, which result is this? Let's try and plug this in this way. Let's see. 6 point something or 8 point something. The more gravity we add, the better result we have. Something like minus 2, 3, 4. Okay. Something around this is working well with 5. So as I said, I'm going to say that our maximum length is going to be add this vector. I'm going to take its length, add it. Now we've lost something. Okay. 2, 5. Yeah, something around this. When decreasing the length, we're decreasing the accuracy. The more length we have, for example, no, that's too much. For example, 10. Oh shit, man. It's something to do in here, but I can't figure it out. Before this, like when playing with the position, we're adding to the z-axis the gravity. And we're doing the same here. Let's say that I don't want to add this here. Let's see how is this going to behave without, without. So there is totally no difference. Let's get rid of this. Let's remove this. I wanna make it fixed length rope. At the moment we have one watching, which is me. Anyway, it's supposed to be 10 meters. So if I connected this, 0. But why? Why is it 0? The gravity is going to give its effect and plus stuff, but we need a pinned point. This pinned point is this one. Which must climb up. Wait, let me just increase this. Hell no, buddy. The curve now is dancing. Okay. Something is happening, buddies. Let's multiply by the length of the gravity. Here we go. That's so cool. I'm just kidding. Okay, like this. Damn. So we have to subtract that. But what is the length of the gravity? Like, for real. What's causing this? Let's go to the first frame. The viewer is showing me a lot of different values. These values are... Wait. Yeah, that's what I have to look to. Okay. And by multiplying this by this, we have a total of 1. By moving this, I'll just leave it. 0.3. Then let's just do a small test. Not here. Yeah. By reconnecting this, it's kind of working. But as I said, when we're going to the, for example, maximum length 2, it's 2 point something. So how to fix it? Increase this. So I have to map range this between some random values, I think. Wait. Let me just type them down. All right. So length, wait, a table. I'm going to do a table. L and M, which M is the multiplier. So when L is 2, the multiplier should be 2. Let's try a different length, for example 1. Okay, I can go that far. 0.001. Nope, something stronger. Something more. 0.3, 4, 7 maybe? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Man, what the hell is going on? 3 point something. 4. So when the length is 1, the multiplication should be 4. But once I restart, so it has to be map ranged by pair frame from into. Let me just do it. Map range, frames. No, scene time, frames. So let's say at the first 75, let's say up to 4. This example. Nice. So if the length is 2, so this map range is going to be based on the length. We're going to add another one based on the length. So let me just grab the length. If the length is, for example, 10, let's see how, oh shit, it can't be 4, right? Like, indefinitely. So I'm going to pick, yeah, let me just put this in here. So 1 is 4, 10 is going to be, for example, 0.1. Something much stronger. Wow. 10 is 0.4. So what is the relationship? 2 is 2. 1 is 4. 10 is 0.4. So the division, let's say 4 over 1 is 4. But 0.4 over 10 is not going to do the same thing. 1 over 4 is going to give us 2.5, no, 0.25, a quarter. 10 over 4 over 10, which is going to be like this, is going to give 25. Let's try, for example, 5. Is it going to need, for example, this means The value of 5 is going to need a half, I think. Let's give it a test. Increase it a bit. More, less. That's so weird. So we have this value, then we have to double it. This value, we have this value, then we doubled it. But what is this value? The multiplication of them is 4. So the curve length, which is L, in all the situations, L times M is equal to 4. So we want to find M, which is going to be 4 over L. This 4, wait, I figured that out. This 4 is the edge count, I think. I'm going to test it. Edge count. So let's have a look. We're going to say, instead of the map range and all that stuff, we want, yeah, let's leave this. The maximum length, we said, over, yeah, 4 over this. So divide 4, which is the edge count over the length, is working. Now let's try 1. It is not working. Is it because of the map range? I don't think. Like 4 over 1 is 4. And it worked the previous time. Yeah, it's not connected. My bad. Damn. 7. 3. Yay. Okay. You can't change it in real time because you're going to end up with some issues. No. Let's map range it from the current frame to the frame math add 75 frames, for example. So we can do it in real time. Let's have a look. Oh shit. The current frame, yeah. Okay, never mind, a bad idea. I thought that it would work, but my small brain. So let's play around with the count. For example, let's say it's 10. Now that's not going to work, right? So let's say that we have 10. Oh, 9, yeah. With a length of 2. With a length of 4. So the more we have, the more count we have. For example, 15 is going to cause much more error. So let's say 14. Let's give it a try. As we can see, the more points we have, the more point count, the worse it gets. So let's go back to 7, for example. We have to divide 6 over this value, which is working. Let's go with 3. Okay, so all I have to do is to get this count, divide, no, subtract. No, what the subtract, the normal subtract, the normal math, subtract 1. With that, I can say that I'm done. Let's add more frames for the rope to fix itself. An exact 4. So let's go up to 15, for example, and it's NAND, but now it's in a certain point it fixed itself and some weird stuff started happening in here. After this point, 4 point something, it started doing this weird stuff behavior. 14 is working pretty well. 16, for example, is working well, but 15 is not working. Let's try 5. 5 is working. 20. But 21, for example, I know it's not very accurate, but if it works, it works. Why 15 is not working? As we can see, 23 is not working too. No, it's working. But with this, oh shit. Let's go with 100 and give it a test. The PC is lagging. 100 is working pretty well. Okay, okay. Please work, my body. Please work. But surely I'm not going to do something this high. Okay, there is a little, there is a small inaccuracy in this setup, but it is kind of working. So let's go down to 40. Let's give it a try. And not bad. 2 meters. Okay. Not going to complain about this. Dang. Man, it's so amazing. Love it. Okay, so let's just, yay, buddy. A fixed length rope. So how can we make it much more quicker? Because as we can see, the count now, okay, it has to be 3 in exact amount, yeah. Let's try and just do some weird stuff in that. Nice, it fixed itself. It's fixing, so let's try its best. Anyway. Yeah, this table's done. Okay, by increasing the iterations, we're going to have a quicker result. But nobody cares, like it's not a very noticeable thing. Going back to here. Okay, so this is a ridiculous idea. Let's just remove this and this. And let's try and see what is going to happen. But with that, okay. So we want to do something to this point. Even if it collided, it's working. Let's try and put this inside the repeat zone, but before or something like this, yeah. Same result, but I think now if I disconnect this and bring the controller, no, I need the static one. Relative location, position, and we will have this happening. Yep. So let's mix between them. Mix vector. As I said, the mix is going to be based on something, but we're going we want to go much more towards the position, so our current position. Yep, it's doing something. Let's say a small value, 0.001. We're not going for something that is very accurate. Something that works. That's all I need. So let's try and connect it. Connect yourself, buddy. It's still not working because I have to increase this a bit more, more, more. Something like 0.1. Okay, let's see. If I grab the count, divide 1 over the count, I think. Oh, I need smaller value, a very, very, very small value. 0.1 over the count. Let's see what is going to happen. The same thing. Into map range, I think it's the best thing. A map range. Map range, yeah. So we have this selection, which is yep. So we want if from max, which is the count, the more count we have, then the less we want to. So let's go from 1 down to something. Wait. Yeah, from max down to something. This thing is going to be 0.0001 maybe. Nah. Let's map range it between 150 to point something very small. Is it going to work? Oh shit. So I need to map range it to smaller value. No, buddy. What is going on? Let me increase just this a bit. Much more. We started doing something. Much more. Here we go. Is it going to break? The answer is no. But because of this points jittering, I think, not sure. So let me just wait. 150, for example. Let's see. Yep. 0.301. It is kind of disconnected. Anyway, I'm not going to do something with that resolution, so 50 is going to be enough for me. And instead of this high value, I'm going to 002, for example. Like, I really wish it can be better for, I don't know, just stretched more. Maybe I'm going to do it in the future. As we can see, let's add a different cylinder. Alt R, rotate it 90 degrees. As we can see, now we can just do this. Because of the gravity, the rope is trying to go downwards. This one's trying to go this way, but the rope is fixing itself. That's why it's behaving like this. Anyway, is the length 4? The answer is yes. And the cool thing is that this point is going to collide, I think. Let's just rise it up, move it to the X a little bit. Yeah, it's colliding. So let's, for example, add a big wall. A really big wall in here, and let's see what is going to happen. Yeah, okay. Only this point is passing through, otherwise, nope, you are not allowed to pass. And yeah, here we go. Not 100, yeah, 100, okay. So let's give it a try. Is it going to break? I believe yes. I believe yes. Something around 5 or 4 point something, then it will explode. Huh? Is it working? Like seriously, buddy? Okay, nice. Like, I'm not going to be sad if it's not working. So let's go with 5, for example, and let's have a look. Yep, we don't want to go that far, so yeah, that's much better. Okay, here we have it. So the farther we are, we have to do this based on the curve length, I think, or the distance between them. So the distance between these two, let's see. The distance between this point and this one is 2.7. So let's say that we want to add another map range in here into this socket. For example, to the max and to min, and the max is going to be 0. 0? No. Let's go. Okay, if it's 0, we want to go with 150 and with 001, for example. Okay, so the map range is going to be based on the distance between this one and this one. Shift D, Control Shift. We want to see the distance. So the more distance, the less we will add. So if the distance is the more distance, the less we're going to add. Yeah. Okay, so if the distance is 0, we're going to add, for example, 0.05. Otherwise, we're going to add this one. Let's, oh shit, maybe I flipped it. This one's going to be 0.05. Let's go further. The further we go, as we can see, maybe it's too strong. Just a small effect. 5, for example. Wait, let me just increase it up to, no, decrease it to 2. Nah. But this value is only going to be added 100 meters far. 0.5. Yeah. So let's go. Way to what the okay, which one's worse? This or this? I've no idea. So the curve length is something between 4.4 and 3.9. Okay. The count multiplied by the distance, maybe. Let's give it a try. Count multiplied by the distance. So the more count, the more distance, the less we're going to have, right? So now it's land. Now it's working. So let's set this to 0.2. Nice for the moment. Not nice. Okay. Okay. Let's, okay. Yo, this value is too small. That's what we have to do. Now it's working very well. As you can see, it's trying to go that way. Or you can disable it. So my personal preference. I'm going to add all these controllers and stuff. This thing is going to be available on the Blender market, but I don't know when. Anyway, let's try playing with the count. For example, 50. Is it going to explode? Is it going to explode? The answer is no, buddy. It will not. Is the length going to be 4? The answer is yes. Nice. Like, that's very nice. I'm really happy with it. What other stuff we can do is to, for example, increase the iterations count. Like the count, let's go with 1 just to see the difference. As you can see, that's 1, that's 50, that's 100. So the fixing time, or the fixing, yeah, is going to be depending on the iterations count. But I don't know. Let's go with a very low value and give it a test. Yeah, 15. I don't know what the f is going with 15. 24. Let's restart the animation. Here we go. Nice. Okay. So let's start doing some different stuff. We're enough of the simulation right now. Yeah, I don't want to do more simulating stuff. Let's give the curve a shape. But before giving it a shape, let's see the length. Wait, let me bring this back. The length is going to, yeah, something like this is going to break it. So the more stretched it is, I want to add more of friction. Which one I'm using right now? The test, right? Yeah, I fixed it. So this one, I don't need it anymore. So let's delete it. Deleted the Blender files. Q, node options. I want to just take this. Okay, here's what I'm going to do. Control Alt G to bring this out of the node. Then let's have a look at the node groups that I have. We have the fixed, which I'm not going to, delete it, delete, and the test one. Yeah, let's play it back and see what we will have. 4. Nice. Okay, so the more length, the more I'm going to stretch this more. Okay, and the less length. No. Okay, I want to map range, based on something. Oh shit, man, it's so sticky now. Something between 2.5. Well, that's, as you can see, point what? So 0.5 is not going to do anything stupid. Yo, that's clean. Something like point what? Let's see, 0.25. Yeah. Okay. No. Okay. So we want, as I said, based on the curve length. Curve length. Curve length. The curve we want is our curve, which is located in here. Alt P. Then let's plug this in the, no, what the fuck? This one, yeah. Alt P. Then let's bring it up. Alt B again. Then we are going to map range this one. We're going to map range it if we're going to take the maximum length up to any value which is more than the max length. Let's say the map maximum length multiplied by 4. Then we want to place something between 0.5 and 0.25. Okay, let's have a look. So now yay, nice. Let's try and flip them. 2, 5. Is it going to behave the same? You know, 0 and 1 just to test it. So this thing is now very smooth. The 1. You know, it's too much. Let's go with 11. So if the length is 11, we want to range it. No, this one's 0, this one's 1. Let's see. 1 and 0 from 7, you know. Bro, you have to try and fix yourself. Okay, so the thing, if the max length plus 1, let's add a small value. That's it. I'm not going to do the exact same, the exact amount. No. Okay. I think I flipped it. 0 and 1. Let's restart the animation and have a look. Okay. Not exactly this. Like I want to go, as I said, 0.2, 0.3 down to 0.5. I'm streaming for 2 hours. Okay. So now we have it. A rope with a fixed length and everything. Now, I don't want to see this, or this, or any of all that stuff. All I want to do is to give the rope a shape, because it's so boring to look at a line which we can't render. So what I'm going to do is curve to mesh, CTM, and we want CC curve circle with a very small radius, like 0.1, I think. Yeah, let's give it a try. Damn. So it's trying to go here, as we can see. Okay, never mind about what happened. Okay, so because of this bad movement, something we can do, which is not good, is resampling the curve with a really high resolution. Currently I have 24, so we're going to just go with 100 maybe. With okay, there is no difference. Shit. Anyway, what can we do with this curve? Let's see. with this rope. No, Kev. Let's try and put it in here, something like this. Ooh, that was weird. Okay. Let's drop this one down and try to do something like this. Very nice. Okay, let's try and add much more of those. Then increase the length. For example, 15. Okay, so as we can see, the static point is controlling the last point. But if we try to do something like this, the rope can't shrink into itself. So that's nice. Like, okay, so what we can do is to bring this to the other side like this, maybe. And the rope is trying to fight to reach this point. You can do whatever you want, as you can see. And the rope is going to try and have this fixed length. So let's shrink it down like this. Okay, as you can see. Something to mention. The collision system that I made, just let's bring this away because it's behaving in a weird way. Let's drop it down to 15, for example, 10 maybe. Yeah, what I want to show you, let's just do this back to the first frame. Okay, so they are on the same line. Okay, I'm going to add a cube, move it into here and add one loop cut. I'm going to drop it down because this collision system is broken a bit. So now after use, okay, now the collision is not going to work because it hit an edge instead of a face. So the collision system is not going to work when a particle or point hits an edge. So yeah, just all you have to do is do this, and here you go. Let's say we have Suzanne the monkey and we've added it in here. As we can see, we're not going to collide with his face because it's filled with a lot of sharp edges. Wait, what the okay, because it's filled with a lot of sharp angles, as you can see. How to fix it is maybe subdividing it. I'm not sure, I didn't try it. As we can see, we're running too slow because we're calculating a lot of normals right now. So let's drop down the count down to 15, maybe this one to 2 meters. We're just trying to see the collision. Okay. Shit. Control 1. Something very, very low. F15, the cursed number. Now let's give it a try. As we can see, it's not colliding very well with the face. Yeah, something to put in your mind. So the more geometry you have, the better colliders you will have, because of you're not going to run into acute angles. Okay. Let's try now with 2 levels of subdivision. As you can see, it improved a bit, just a small tiny bit. Yeah, so that's it. Let me just turn the shadows of the cavity off to get a better performance. And yep, let's increase the count up to 20. Let's see. So the more resolution, the more or the better colliding you will have. Let's see in here. Yeah, okay. Some parts can pass, some are just trying hard to pass. I don't know. Like that's the best collision that you can make using the repeat zone, because we're currently repeating this collision thing 20 times in frame. So we're raycasting 20 ray multiplied by the count. So 20 rays times the count, 400 rays per frame. Like that's too much. Imagine using 400 raycast node. So yep. And let's remove the monkey because it is high dense, and you know. What other stuff should we do? You know, let's make it look like an actual rob, like a real rob. So we need a cursor circle with a lower resolution, 4 for example. Then go to the top view. Let's just look at the circle with a resolution of 8. We want to duplicate elements for 3 times, maybe 2 times. Okay, 3 times. Then I don't know, I'm going to try something. What I want to do, let's go to the first frame. I can't see the circle right now. We want to duplicate a spline there. Okay. I want to just set position, or maybe rotate elements. Is there rotate elements? No, element rotate, no. Instance, it's only instances. Shit. Like I was thinking about doing an array. Let's go with the transform geometry. Plug anything in here. Control H. Just disconnect it. Let's see. We have an index of 0, 1, 2. We want to rotate each point. First, set position. We want to offset each point by a certain value. Then we want to rotate them around the z-axis by I don't know, by a certain amount. So let's go with 0.2 for the set position. Then we're going to multiply the duplicate index, multiply by, for example, 120 into 2 radians. I think it's going to convert this into radians or to degree maybe. We will see. Combine XYZ. This one's gone to the Z, and let's see. We can't plug a field. Rotate. No, instance rotate. Rotate instances. Instance. This one. So we don't have instances, so let's do geo to instance. For the rotation, we're going to use this one. Okay. So let's plug this in here. Then this one is going to be the instance. Yeah, here we go. Okay. Then we're going to convert this to radians. Here we go. So now what we can do is to just play with this. And a nice way to do stuff is by setting this to math, another math. Then we're going to put 360 divided by a certain value. And what value we want, let's add a controller, new output, which is going to be curve, for example, circles amount in the final looking shape, which is going to be an integer from 0, no, we want it from 1 up to 5, for example. Maybe you want something really high like 10, I don't know. So this amount is going to be plugged into the duplicates, and in here, now when I collapse this and add like 3, let's see the viewer, yeah, here we go. So let's plug this into instance to curve to geometry, or yeah, realize. I know this thing is heavy, but there is no other way. Then geometry maybe to curve. Geometry, I don't know. Let's try and plug it and see if it's go. Yeah, it worked. So let's see, group all that stuff. Ctrl G. Let's call it rope shape. So as I said, we're going to go from 1. Here we have 1 point. Okay. So I want to do some other stuff. First thing, the rope is working. Like, let's increase it up to 6, for example. It's working like Kramer. You can make Kramer with that. Surely there's no self collagen, but you know, it's looking so good. Tab out. So let's find the relationship between what and what. Let's have a look only on this. So based on each circle radius, we're going to add this value. So let's say we want to add 3 circles. Yeah. So here is the thing. I want to take this and map range it. Map range from 0 into a combine XYZ. This is going to be in the Y. Okay, so if the count, let's see, from 1 to 10, from 1 to 10, If the count is 1, we want to return this. If the count is 10, we want to get the radius. Let's set it as a global, another global thing. Output. Each, radius, just radius. Like this. Let's set it to 0.1 or now. So this one multiply it by 2, plug it in here. Maybe more. So let's try and play with the radius. As we can see, the circle amount, as we can see, it's not working quite well. Times 3.33333 times pi maybe. Then let's have a look at if, for example, we are at 3. We want to just change some stuff. Instead of linear, we want smooth step, maybe smoother now. Okay. Wait, so when it is 2, when we have 2 points, we're going to do 2 to multiply this by 2. So let's give it a try now. No. So let's see what will happen. Okay. Then when we have 3, 4, 5, the more we have, the worse it gets. Let's just do it as 3. It's kind of working. So if the count, we want to add a switch. Okay, switch. If the count is 1, equal 1, then we want to get a value. If it is not, give me this map range. And the value is going to be 0. So now I have to plug this in here. Circles amount. The weirdest stuff are happening. If the circles amount is equal to 1, flip it. This one is going to be like this. Here we go, buddies. But why the resolution is changing? Because I'm so stupid. That's the answer. Okay. 2, 3, 4, 5. Okay, you got the idea. I want to add an output in here. Okay, above the circle amount, just above it, I'm going to call it rope shape. I'm just going to do something like this. That's the output name, and the value, I'm going to hide it. That's it. So as a separation between the global settings, the settings that we want to just do at the very beginning of the simulation, and the shape. You can do something like this. So let's duplicate item and then to go rope settings. So the circles amount, like, okay. Under the rope shape, I'm going to add another one output, which is going to be tilt. No, all caps. Tilt, which is why I'm writing it like tilt. Let's remove this. I don't know what is the socket. Maybe no, I don't know. No idea. Control H, yeah, here we go. So we have the tilt, we have count. Yeah, we have. How did I do that? Another output, which is going to be a tilt. Yeah, like this. It's going to be a float with, which is going to be a, where it is, yeah, factor from 0 up to 1. Let's set it to 1. And what I'm going to do with the tilt is before what? Before this. No, no, I'm going to do something outside. Let's get an input and out. I have no idea. Just, okay, controllers, tilt. Then I'm going to index, multiply it, or first add 1. Then going to just show you how you can do the maximum tilt you can do for a curve. Multiply it by 4, pi over 4. Then I'm going to just set curve tilt into this value. I don't know what the selection is. We're not going to play with the selection, so let's remove it. Let's see, with not a big difference, but this value in here, wait, let's increase the count. You know, let's just reduce the radius because it's too much. So something like 0.05, 0.02. All right, so without this, not a big improvement. Anyway, so as you increase it, the tilt is going to just increase. But as you can see, so the most smooth thing I found was something like pi over 2, or no, that's not it. Yeah, maybe you can set it to pi over 2, then just subdivide it. Yeah, I'm going to pi over 2 at the moment. Then in here, I'll plug this into map range, something between 0 and this value. Plug it, control edge. Now we can control the tilt like this. Amazing, nice. Something like this is nice, I think. And here we go. More settings. So as you can see, we've did quite a lot of stuff in this live, which nobody is watching. Shit. Anyway, so let's think of what to do next. Let's go to render. Then let's add a sky texture. The mic is working, yeah. Where's the time? Okay. Sky texture. Then under here, false color. Everything is high intense, so I'm going to bring it down to something like this is fine. AJX, nice. Here we go. Maybe, I don't know. Anyway, let's try and set a material for the robe. So first thing, let's subdivide it, maybe. Yep. So what I want to do now is playing with the robe shape, because you know. So go into shader editor, and here set material, which is going to be rope. But this material does not exist, so let's make it exist. Rope. Then in here we have rope material, which is at the moment white texture. So let's see what will happen if let's look from this angle, for example. Let's just make some nice looking stuff with the rope. Like, let's increase what, the length to 4. Have a look. Yep, something like this. Okay. Let's have a look at this rope now. Let me increase the exposure a bit. It looks like a jelly. I don't know why. Anyway, so a small tint of a brown color with more roughness, less index of refraction maybe. It's looking bored, you know, but I'm not going to UV unwrap it because I don't know, I feel lazy now. Maybe something like this tone. It's not looking realistic, but you can instance some points, for example, in here. Wait, let me just show you something. Let's go with this. You can just instance some points. Then we want to instance a mesh line. Here we go. With a count of 2. The length is going to be some small value. 0.03 maybe. Then Control Shift and just join them together. You can just do a curved line and give it some thickness, but I'm just showing you the idea. What we can do is to set normal. But okay, you know, I'm actually shocked it worked. I was thinking of another thing, but never mind. So the points I want, let's do distribute points on faces like this with a really high density, 100 maybe. You can now plug this normal directly in here, which will give you a much better result. For example, this high dense rope. Now it will look something like this if you just, as I told, like it's like a hair particle system. But I want mine smooth and as it is. Let's I don't know. So if you want to make wires, for example, you can make it black. Anyway, you know, okay, I think that's it. I'm going to just play around with some settings and render it, post it on Instagram, post it on, I don't know, maybe as shorts in YouTube, on Twitter, and that's it. Thanks for watching, goodbye.